I am Anil Kumar. Welcome to my YouTube channel. Let me thank all the viewers and subscribers watching my videos, posting excellent remarks, and sharing with me some brilliant questions. Now, these questions make all the difference since I take up my time to explain how do we solve such questions. In this particular video, I'm discussing with you the Descartes rule of sign. It is related with finding the roots of a polynomial. For a long time, many questions on this topic have been posted. Now, in this video, I'm going to address all of them. In case you want to learn from me, you can always send an email on the address given. Also, check our website for the latest videos. So, we are going to discuss in short what do we really mean by roots of a polynomial, some basic concepts, and then get down to Descartes' rule of sign. So that really tells us how many possible, let me write down, how many possible positive roots and possible negative roots. This is most important thing. If you know the number of possible positive and negative roots of any given polynomial, you can cut down your time to find or factor the polynomial very much by almost one third of a time. Now, to practice, we'll also take some examples, right? So, what is a polynomial after all? Polynomial, as you can see here, is written like this: an x to the power of n plus an minus 1 x to the power of n minus 1, and so on, till a2x square a1x plus the constant a0, where x could be any complex number. Now, for the benefit of some of my students who may not know what complex numbers are, so the complex numbers basically include all the real numbers. So if we have real numbers R, in that case, complex numbers include all the real numbers, and the only number which make all this difference is iota, I. Now this I is basically equal to square root of a negative 1. That is what it is. You remember the quadratic equation? Well, let me remind you of that. When we solve and try to find the roots of quadratic equation, remember, solving means what? Solving an equation means equating the equation to 0. Finding the x-intercepts means the real roots, right? So, ax squared plus bx plus c equals to 0 has a solution, which is x equals to minus b plus minus square root of b squared minus 4ac divided by 2a. This, you know, is called a quadratic formula, correct? Discriminant d, which is b squared minus 4ac, helps us to figure out whether we have one real root, two real roots, or no real root, correct? So if b squared minus 4ac is greater than or equal to 0, then we do have real roots. It could be one real root or two real roots, correct? However, if b squared minus 4ac is negative, less than 0, in that case, we only have complex roots. Now, important thing is to remember that these complex roots exist in conjugate pair, right? That is to say, there is never a single complex root. There will always be even number of complex roots, right? So that plus and minus makes it a pair. Do you see that plus and minus? That is the reason. So whenever you have complex roots, you could get two complex roots, correct? So we could actually say here, in short, that if I is square root of minus 1, I square is what? It is minus 1. So till now, in the set of real numbers, we always thought that square is always positive, right? But iota, I, this complex number with magnitude of 1 has a square which is -1. Correct? That is key to understand. It is for the benefit of those students who haven't learned complex numbers so far. Okay, so I'm going to make this video very simple, which could be understood even by the students who are working in the domain of real numbers. Is that clear? Okay, so it's beneficial for both. Now, let me give you a concrete example. If I take x squared minus 1, this is difference of square. You could factor as x plus 1 times x minus 1. It means what? It means that it has two real roots. One root is at x equals to minus 1, the other one is at plus 1. Correct? Root really means what makes the factor 0. Minus 1 makes x plus 1 0, and plus 1 makes x minus 1 0. Well, if I have a factor, a term, x squared plus 1, let's say a polynomial, x squared plus 1, can you factor this? Well, not in the domain of real numbers. This could be factored when x belongs to complex numbers, right? So this is where x belongs to real numbers. You get the difference. X square, square of a number in the domain of real numbers is always positive. So it will always be greater than or equal to 1. However, iota, the I, square of I is what? Is minus 1. So minus 1 plus 1 is 0. And that is why plus and minus 1 are the two solutions, correct? So we have two roots here, complex root, both are complex roots, and these are plus and minus iota. Do you see that? You can say plus minus iota or I as you wish. So I think you got the concept from this particular thing, right? We'll explore this. We'll learn more about what are some formulae for sum and product of the roots. We'll see. We'll try to understand polynomial roots a bit more, right? So let me take one more example. Now, in this example, we have a polynomial, and what is the degree of this polynomial? Well, the degree of this polynomial is n, correct? So let me write down. Degree is n, and that is decided by the highest power. Whenever you are given a polynomial, what you should do? You should arrange this polynomial in an order from highest to lowest degree of the single variable x, right? So degree is n, which is basically highest exponent of the single variable x, correct? So which is this? Now what is an? Well, an is called the leading coefficient, correct? We also know that an is leading coefficient. Let me write in short, and a0 is constant. Correct? So these are other important terms which we have to look into when we are talking about a polynomial. Correct? Now, here the question is, how many roots will you have for a polynomial of degree n? It is important to understand that the total number of roots of a polynomial of degree n is always n, correct? So number of roots is constant, which is equal to the degree of the polynomial. And we have also learned that the complex root could exist, and they exist always as conjugate pairs. So even number of complex roots. Is that clear to you? Perfect. Now, when we are saying that there are n roots, n means what? How do you count the roots? A root of multiplicity k is counted as k roots. If I have x square, that means x square will give me two roots at x equals to 0. You understand? That is what it means. To explain this further, here are examples. So if I have a factored form of a polynomial, x plus 1 times 2x minus 1 times x minus 3 whole square equals to 0, how many roots are there? Well, 1, 1, and 2. add them up. This is multiplicity of 2. Do you see that? Or we say order of 2. So count this as 2, okay? So we have 1 plus 1 plus 2. In all, we have 4, and all 4 are real roots in this case. We have 1 negative root and 3 positive roots. Do you see that? 1 negative root, which is minus 1, and 3 positive roots, which are half, and then we have 3, and we have 3. So, so these are the 3 positive roots. In all, 4 roots. You see that. Next example here is when we have a factor x plus 2, x square plus 1, and x minus 5 whole square. How many roots are there in this particular case? Well, this gives you one root, right, which is minus 2, correct? This actually gives you two roots, plus and minus I, as we discussed earlier. And then we have two roots here also, because the multiplicity is 2. So it is 5, which is repeated twice. You see that? So we have 3 real roots and 2 complex roots. You get the idea. 1, 2, and 3, 5 being repeated, are the 3 real roots, and then we have 2 complex roots, which are plus and minus I in this case for x squared plus 1. So that is the basic concept. Do you understand? How do we count the roots? How many could be maximum number of roots? How many are positive and how many are negative roots, right? Now we will see how do we figure out these number of roots, okay? And that is given by the Descartes rule, right? That is given by the Descartes rule of sign. We are going to discuss this now. Once we discuss, after that, I'm going to take 7 examples. So these are the examples one by one. We'll try to understand these polynomials. How many positive roots are there? How many negative roots are there? And once we know the number of negative and positive roots, we can actually very fast calculate the possible roots, right? You get the idea? So we'll also touch upon how do we factor such a polynomial where the domain of x is complex numbers. In fact, we'll get into details of this in the later half of our video, which I'll call as part 2. So let's begin with the Descartes rule now. So I hope you have understood the significance of today's lesson. Okay, so let's talk about Descartes rule. First thing to remember is that the polynomial should always be written in a proper order. You get the idea, right? So a polynomial should be written in standard form with non-zero terms in the decreasing power of single variable exponent. So highest power first for this single variable x, and then in the decreasing powers, right? Do not include any term with zero coefficient, correct? So clearly here in this case we have a is not equal to 0. All the ai's where I is from 0 to n are not 0. Okay, that means non-zero terms. Now let us figure out the rule for finding positive real roots. The number of positive real roots of a polynomial f of x is either equal to the number of sign changes between the consecutive coefficients or less than it by an even number. Why less than it by even number? Because if there are complex roots, they are always in conjugate pairs, correct? That is why. So what we need to do is to check change in sign, right? So we have to change equal to the number of sign changes between the consecutive coefficient, means like this, right? The consecutive coefficients. We'll take up an example to explore more, right? That's what we are going to do. And in the second case, how do we find the negative real roots? The number of possible negative real roots. In that case, we explore the function f of minus x. We get the negative real roots. Yes. So it's the same definition. To find the negative real roots, we actually find the negative of f of x. So how do we do negative of f of x? Odd powers will have the negative value of their earlier coefficients, correct? So we'll flip that. So that's what we are going to do. So the number of negative real roots of a polynomial f of minus x is either equal to the number of sign changes between the consecutive coefficients or less than it by an even number, correct? Slightly confusing. Let me take some examples to really understand this definition. We'll begin with a very simple example where f of x is equal to x cubed plus 1. Can you tell me how many roots are we going to have for this? Well, we know that the degree is 3. So the number of roots will be equal to 3. That means we could have real or complex roots. Total will be 3. Perfect. Now, with the rule, we have to see change in sign. To find number of positive roots, change in sign for f of x, right? So let's see change in sign. Is there a change in sign? No change in sign, right? Both terms are positive, correct? X cubed plus 3, both are positive, no change in sign. Clearly, that means that we have only 0. That means no positive real root, correct? Okay, now let us write down the function f of minus x, means converting x to minus x. So that means, how do we do it? We'll do f of minus x as equal to minus of x whole cube plus 1, and odd powers of negative will flip the sign. So it will be minus x cubed plus 1. Do you see that? That is why I have written minus x cubed plus 1 for f of minus x. Now count the number of change in sign. Well, it changes once, right? From negative, it goes to positive. It changes once, and therefore, we know that it has one negative real root. So when I write negative root, it means a real root. We're talking about real roots now. The remaining will be complex roots, correct? So from here, clearly, we know that there is no positive root, but there's one negative root. So how many complex roots? So that means we have 3 minus 1, which is 2 complex roots. Is that clear to you? So we can actually figure out, even without factoring, how many negative roots, how many positive roots, and how many complex roots are possible, right? So this is the possibility, right? So we will always say possible. We'll have to do some more calculations, rather factor it, and then see exactly what are the roots. But at least we have an idea. So that really means we have to only try the negative numbers to make this function 0, right? So as soon as I write f of negative number which is possible is minus 1, so we'll test f of minus 1. And we know f of minus 1 in this case will be minus 1 plus 1, which is 0. And therefore, that is a root, right? So x x cubed plus 1 could be written as, since minus 1 is a root, x plus 1 times. When you divide, you get x squared minus x plus 1. Well, this is a very simple example. You know what is x cubed plus 1 expansion, correct? And that is how. We just use this expansion, a cube minus b cube is equal to a minus b. You know the factored form, correct? If not, remember this formula. A square plus AB plus B square, correct? This is when we have A minus B. However, if we have A plus B, the sign changes. That is the change for A cube plus B cube. We've used this formula A cube plus B cube and written the factored form. Now, from the factored form, you can see that there is only one real root, which is at x equals to minus 1, and the other term gives you two complex roots, correct? So this gives you two complex roots. Now, in this video, we will not be calculating the roots, the complex roots, but you could always apply the quadratic formula, which we discussed earlier, to calculate the complex roots. Is that clear to you? So to calculate the complex roots, you apply this particular formula. So when you have the quadratic equation, apply this formula and calculate the complex roots. Is that clear to you? Perfect. So that is how you'll get the two complex roots of the other factor. One real root is very clear, x equals to minus 1. Now let's take up more examples. Example number 2. I'd like you to now pause the video, answer this question, and then look into my suggestions. So we'll begin with finding the total number of roots. Since the degree is 3, the total number of roots should be, yes, 3, correct. So that is including maximum, that is the maximum number, which includes positive, negative, or complex roots. How many possible real roots are there? Let's look for a change in sign. So in this function f of x, the change in sign is only once, correct? It changes sign from plus to minus when moving from x squared to minus x. So that means we have one positive real root. So let me write one positive root. Now, you have to check f of minus x for possible negative roots. So if I make negative, all the odd terms sign will change. So it will be minus x cubed plus x squared plus x minus 1, and that gives me one sign change from the first two terms, and then again a sign change for the next two terms as shown here. Two sign changes means we have two negative roots. Is that clear to you? Or it could be even 0. So we can say 2 or 0, right? So it's better to write right from the beginning in the correct way. That is what we meant, 2 less. So 2 or 0 negative roots. Is that clear to you? So I hope now you have understood the definition. So let's go back to the definition, which says, how do we find the positive real roots? The number of positive real roots of a polynomial f of x is either equal to number of sign changes between the consecutive coefficients or less than it by an even number. Do you see that? Negative real roots. The number of negative real roots of the polynomial f of minus x is either equal to the is equal to the number of sign changes between the consecutive coefficients or less than it by an even number. Therefore, in this case, it is either 2 or less by 2 means 0. Perfect. So that is kind of important to understand. If you get sign changes as 1 or 0, right? If 1 or 0 is the number of sign change, then that should be the number of roots, right? Because now you cannot do less by 2, right? This is very important to note. Is that clear to you? So in the first case, the number of sign change was 1. So for sure, this is like for sure, there is one positive root, right? Here, it could be 2 or it could be 0, right? That is what it is. So that is what. So in this particular case, we do expect one positive and 2 or 0 negative roots. Perfect. Now I like you to actually factor and check the result, right? That's very important. So let's actually factor this. So what I've done here is factored the polynomial. I've used group factoring in this case. We can take common factors from the first two and the next two. So x squared is common, x plus 1, and then x plus 1 when we take minus 1 common. So we can take x plus 1 times x squared minus 1. X squared minus 1 can be written as x plus 1 times x minus 1. When you multiply by x plus 1, we get x plus 1 whole square and x minus 1 as the other factor. So we definitely have 3 roots, out of which we have multiplicity of 2 for minus 1. So we have minus 1, and then plus 1. So these are the three roots. As expected, we were expecting for sure one positive roots, two or zero negative roots. We get two in this case, right? So no complex roots, correct? So we could factor this as x plus 1 whole square times x minus 1. So that really confirms what we had thought about. We have one positive and two negative real roots for the function given to us. Is that clear to you? This is the way to analyze and figure out how many positive negative roots are there. Once you factor, you are sure how many complex roots are there, correct? Otherwise, we are talking about a possible number. Clear? Let's take example 3. I'd like you to actually pause the video and answer these questions now one by one. Question number 3 for you now is f of x is x cubed plus 3x squared minus x minus 3. How many roots are positive and how many total number of roots? Well, since it's cubic equation, 3 is the total number of roots. To find the possible roots, we'll write the function and change in sign will be noted. Only one change in sign is there, so that means for sure we know one positive real root in this case. For negative roots, we are writing f of minus x. Change the sign for the odd degree. So we make these two terms with reverse their sign. Do you see that? So what is important to understand is simple process. Only the odd terms, their sign will change. The even term sign will remain same for f of minus x. Is that clear to you? Now, again, check how many sign changes are there. Well, once we have done here and then once there. That means we have two possible solutions. We could have two or zero negative roots, correct? When you factor this, then the factored form will come out like this. So here we confirm that we do have two negative roots, correct? So in this case, we have a negative root which is negative 3, we have a negative root which is negative 1, and then we have a positive root 1, correct? So we have 2 or 0, right? Negative roots. We confirmed that we have 2 after factoring only. You get the idea. So we get this as a possible solution, right? This is possible. Either 2 or 0. So once you factor, you really get your answer. 2 negative roots and 1 positive. Clear? Now let's move on and see how do we do the next question. So now, I'd like you to pause the video. F of x is x cubed minus 5x squared plus 16x minus 30. Very similar to previous question. Therefore, I just termed it as 3. And what you need to do is that write down your answer. Correct? Cubic equation means 3 roots. Combination of all the roots. Now, possible positive roots, check the change in sign. It changes once here and then again at this point. So, how many roots? And it also changes here. Do you see that? So, positive to negative, negative to positive, and then from positive to negative. So, basically, we have 3 or 2 less means 1. So, the both are possible, 3 or 1, right? Maximum 3 positive. You can also say like this. So, we have maximum 3 positive roots, right? Otherwise, 1 for sure. Is it okay? At least 1. Okay, now, number of negative roots, write down f of minus x. Once you write f of minus x, it really means reverse the sign for the odd terms. Do you see that? We reverse these signs, and now we're checking the change in sign. Well, there is no change in sign, 0 negative roots. That means for this polynomial, only positive numbers should be tried. Do you get the idea? So all the factors of 30, positive factors of 30 will be tried for the roots, and then you'll get your solution fast, right? When you do that, you'll get 3. F of 3 is 0 for this particular function, right? So what you get here is that if you do, f of 3 is 0, that means that is your positive root. Then you divide by the factor, which is x minus 3, to get the other factor, which is quadratic in nature. Now, since this is quadratic in nature, you can find b square minus 4ac, right, to check whether it can be a complex root or not. Clearly, b square minus 4ac in this case is less than 0, and therefore, both the roots are negative. I'm not calculating those roots now, but I'm just confirming that we realize that we have maximum 3 or 1 positive, but no negative, and that's what we got. We got 1 positive, right? So it confirms that we have one positive root and zero negative roots. Since it's a cubic equation, the other two roots are complex, right? It's your duty now to find those roots. Is that clear? Use quadratic formula. Correct. Now, let's move on to example number 4, which is degree 4 polynomial 2x to the power of 4 minus x cubed plus 2x squared minus 4x minus 24. Total number of roots is the degree, which is 4. Number of positive roots, well, let's see the change in sign. It changes once, then again it changes, right? Then again it changes. So 3 times. So that means it could have 3 or 1 positive root. Maximum 3, minimum 1 possibilities for f of minus x. Reverse the sign for the odd terms, right? And once we do that, let's figure out the change in sign. Well, there's only one change in sign, so for sure, one negative root. Is that clear to you? When you factor this, what you get is something like this. So I'm leaving this part to you. Apply remainder theorem or the techniques which you have learned to factor. At least we know what are the possible factors. It is better to try. We know it is 1 and 1 at least, right? So you could try with even or odd numbers. Once you do that, you do get one positive and one negative root using these two factors. The other factor, gives you the complex roots, correct? So that gives you the complex root plus minus 2i, right? So that gives you plus minus 2i as your complex root. Here we have minus 3 by 2 as one root and plus 2 as the other positive root, correct? So it has two complex roots. Now let's look into example 5, which is f of x is given to us as 2x cubed plus x squared minus 25x plus 12. How many roots do you expect? We expect 3 roots clearly. How many of them should be positive? Check the change in sign. There is one change of sign and then again it changes. So there are two possible positive roots or 0 positive roots. Is that clear to you? So there are two situations, 2 or 2 less. Okay. To find the negative number of roots, I will do minus of x. So that means we are just reversing the sign for the odd terms. Once I do that, then let's figure out the changes in the sign. It changes once and then that's it. So there is definitely one negative root. So we are sure about one negative root. Is that clear to you? So positive roots could be 2 or 0 and one negative root. So I like you to factor this. Once you factor, you do get a factored form, and in this factored form, you can confirm that there are two positive roots and one negative root. Is that clear to you? The idea is to understand Descartes' rule of sign, and I hope by now you got the concept. Let's go through the last two questions now. We again have a cubic equation, 3x cubed plus 4x squared plus 7x plus 2. So how many roots do we have for this equation? Order 3. So number of roots are 3. Change in sign. All are positive. So for sure, we have no positive root, correct? Now, let's find f of minus x. F of minus x really means changing the sign for the odd terms. So which are minus 3x cubed and minus 7x. Now, let's count the change in sign. So it changes once, again, and then again. So there are 3 sign changes. It means the possible number of negative roots could be 3 or 1. 2 less, clearly, 2 less. So those are possible. So we have possible solutions, which is 3 or 1. But there are no negative solutions. Is that clear to you? That means you should only try for the negative values, correct? So, out of all the possible solutions, and you know how many are there? With 2, you could have factors 1 and 2, and divide by 3, you could have 1 over 3 or 2 over 3. So these are the possible values to be tried. What we have to try for is only the negative values. So we'll try for negative 1, negative 2, negative 1 over 3, and negative 2 over 3. We need not try for the positive values. That cut down our time by half for the trial and error method. Do you understand? So once you do that, you get actually only one root, which is at minus 1 over 3. So there is only one root here, and that is at x equals to minus 1 over 3, which is real. So we have one real root, which is negative, and that gives you two complex roots. You can use the quadratic formula to find these two complex roots. Is it clear to you? Perfect. So for sure, we knew that there are zero possibility, or there are zero number of positive roots, and therefore we only tried the negative and we got one of them as our answer. Otherwise, this question could have been very difficult. Correct? Here is the last example for you. We have this function which is of order 5. So we are expecting 5 roots in this particular case, combination of positive and negative roots and the complex roots. To find the number of positive roots, we'll just see the change in sign. Sign changes like this: once, twice, right? Then again 3 times, 4 times, 5 times. So the possible roots could be 5, 3, or 1. 2 less, 2 less, 2 less, but at least 1. Do you see that? So maximum 5, right? So we get maximum 5 and minimum 1. That is the number of positive roots which are possible in this case. Now, let's find what is f of minus x. So reverse the sign for the odd terms and then see the change in sign. Well, all the terms are negative, and so zero negative roots. Do you see that? We do not have any negative root, and therefore we are only going to try all the positive roots. So what numbers to try? Since we have 4 and 2, so 4 roots are 1, 2, and 4. Dividing by 2, you get half, right? So those are the values which we will try, not the negative values, correct? So you can try these values and then find for which one of them is the polynomial 0. You'll find the values half. And therefore, once you divide by that, you can factor the other part, and that could be factored, correct? When you do that, clearly, what do we get here? We get one real root and 4 complex roots in this case. So we have one real positive root and we have 4 complex roots. That is a very important question. At this stage, I'll take a break. We'll pause here. I'd like you to actually factor this and confirm the roots of this particular polynomial. In part 2, I'd like you to check how do we solve such a difficult question, degree 5, where there could be many complex roots. Perfect. In this video, I am going to discuss with you the technique of factoring degree 5 polynomial. This polynomial also has complex roots. The example is to factor the function f of x, which is equal to 2 times x to the power of 5 minus x to the power of 4 plus 10x cubed minus 5x squared plus 8x minus 4, where x belongs to complex numbers. We'll actually understand a technique to factor this polynomial in the shortest way. We are going to learn few more rules to do the same. In case you want to learn from me, you can always write to me on the email address given. Also, watch our website for the latest videos. Now, we are given here a degree 5 polynomial. Let's try to understand a strategy to factor this polynomial. Well, we know something, that is, the degree here is 5. It means what? That means that we have total number of 5 roots, right? So we are expecting total 5 roots. So roots are basically the x values which will give zeros to the function. We are basically trying to solve the equation 2x to the power of 5 minus x to the power of 4 plus 10x cubed minus 5x squared plus 8x minus 4 equals to 0, right? Solution of this equation gives you the roots. Now, roots could be real or complex, right? So, in all, there are 5 roots. How do we figure out how many real roots, how many complex roots? In fact, the question here is to find out how many real positive roots, how many real negative roots. And then the remaining will be complex roots, correct? So that is kind of exercise which we are looking into. If we have an idea, in that case, we could have a shortcut method to solve this. Well, as you know, the possible roots could be what? Well, the possible roots could be factors of the constant minus 4 divided by the factors of 2, the leading coefficient, correct? So we know that the possible roots could be factors of 4, which are 1, 2, and 4, and factors of 2, which are 1 and 2. So dividing factors of 4 and by the factors of 2, we could actually get all the possible roots. In this particular case, we could have a root at plus or minus half, plus or minus 1, plus or minus 2, or plus or minus 4. That really means that we need to find the value of this function at these x values, 8 of them. It'll take a lot of time. So we should have a way of finding which number should try first, right? That is what we'll look into. So let's see a very important rule to figure out the strategy. First thing first, to find the roots of the polynomial, which is of degree n as given here, the possible roots are the ratio of the factors of the constant a0. So let me write a0 factors, the constant factors, divided by the leading coefficient factors, correct? So those are possible roots. Second, we know that the total number of roots of a polynomial of degree n is n. And also, complex roots exist in conjugate pairs only. That means we'll always have even number of complex roots, right? That is also important to understand. Now, whenever you want to find the roots of a polynomial, it is always good practice to write it in standard form. And that is to say that the term with the highest degree should be written first, right? So x to the power of n, and the coefficient of that is called the leading coefficient. So when you go to the decreasing order, then the last number will be a constant, which is written here as a0. Perfect. Well, some of you may also know the rule of sum, that is, sum of all the roots is the ratio of an minus 1 over an with a negative sign, where an is the leading coefficient, and adjacent to that, the next coefficient is an minus 1. We also know that the product of roots is always a ratio of constant term over the leading coefficient. Now, its sign could be negative or positive. It is negative if the degree is odd and positive if the degree is even. Well, that is also helpful in solving such questions. The most important thing which we are going to discuss here is Descartes' rule, which tells us about the sign of positive and negative roots, right? So how do we apply this rule? And what is this rule? Let's look into this for a moment. Here is the polynomial of degree n written in proper order where x belongs to complex number. Now, polynomial should be written in standard form with non-zero terms in the decreasing power of single variable exponent. That is kind of very important to understand when we are talking about the Descartes rule. Now, if that is done, in that case, we can find how many positive roots can exist. The rule here is that the number of positive real roots of polynomial f of x is either equal to the number of sign changes between the consecutive coefficients or less than it by an even number. Correct? So it actually gives you an idea of what could be the maximum number of positive roots, right? If the number of sign changes are just 1 or 0, in that case, well, the number of positive roots will be 1 or 0, right? Now, we also have a rule which signifies the negative real roots. In that case, we are checking the change in sign of f of minus x. So the rule is that the number of negative real roots of the polynomial f of minus x is either equal to the number of sign changes between the consecutive coefficients or less than it by an even number. Why do we say even number? Because the complex roots are always in conjugate terms, right? Two complex roots in pairs, conjugate pairs. Now, knowing the Descartes rule helps us to figure out from where to try, which value to try, right? That's kind of important. And that is the shortcut method which we're talking about. So here is our function, which is 2x to the power of 5 minus x to the power of 4 plus 10x cubed minus 5x squared plus 8x minus 4, where x belongs to complex number. Now, can you tell me the total number of roots which this polynomial can have? Well, clearly, the degree is 5, and therefore it should have 5 roots, correct? Since the degree of this polynomial is 5. Now, out of these, what are the possible number of positive roots? How do we figure that out? Well, we said that we'll count the change in sign for the consecutive terms. Now, there is one change in sign here. When you go from degree 5 to degree 4 term, correct? Then there's another change in sign. So 1, 2, 3, 4, and 5. So there could be 5 positive roots. Well, also less by 2 or 3 or 1 positive roots, correct? Maximum 5 positive roots are possible since there are 5 times the sign changes for the function f of x, correct? So that gives us an idea. Now let's figure out about the possible negative roots. Now for that, we need to write f of minus x and then figure out the change in sign. So as soon as you put x as minus x, the first term, which is odd term, will become 2x to the power of 5 with a negative sign. This remains as negative, correct? That term becomes negative 10x cubed, and then that remains, even term remains same sign. The odd term degree will actually change the sign. So what do you notice in this particular case? Clearly, there are no negative roots, correct? Since we do not have any change in sign for f of minus x. Is that clear to you? Right? That is f of minus x. And if you check the consecutive terms, all are negative. Right? And therefore, there is no change in sign. Now that gives you an idea that we should definitely start with the positive values only. Get the idea, right? So that means instead of 8 of these values, the possible values of plus minus half, plus minus 1, plus minus 2, and plus minus 4, we are now left with half, 1, 2, or 4. Just 4 values to try. Do you see that? So we have eliminated 4 of the choices. Perfect. So let's begin with the very first one, which is half. So what are we going to do? We are going to substitute x equals to half, right, in the function f of x. So we'll try to find what is f of half, that is f when x equals to half. Substituting x equals to half in the equation and calculating, we get 0. That means x minus half is a factor, correct? That means that x minus half is a factor, or I could write this as 2x minus 1. That becomes one of the factors for the degree 5 polynomial we are looking into, correct? Now, how do we find the other factors? Well, you can do long division or synthetic division, correct? So I prefer to do synthetic division here. We know half is one of the roots, right? So what we do here is we write all the coefficients. So 2, minus 1, 10, minus 5, 8, minus 4 are the coefficients of the function. We are going to divide by half. Bringing down 2 gives us 2 here. Now we multiply and write it here and add. So when you add, you get 0. Minus 1 plus 1 is 0. Half times 0 is 0. Adding 10, we get 10. And then multiplying and writing here, half of 10 is 5. Minus 5 plus 5 is 0. Multiplying by 0 gives you 0. And then when you add with 8, you get 8. Half of 8 is 4. Minus 4 plus 4 is 0. As expected, the remainder is 0. Perfect. So what do we get here? We get the coefficients for a quartic equation, right? Now, so that becomes the coefficient of quartic equation. Since our actual factor is 2 times x minus half, we have to divide all these coefficients by 2. So half of these values has been taken. And now therefore, we can write the quartic equation as x to the power of 4. The cubic term is not there, the coefficient is 0. 5x squared, x term is not there, and we have the constant 4, 8 divided by 2, right? So you're going to further divide all these values by 2, correct? When you divide all these values by 2, you get 1, 0, 5, 0, 4 as the coefficients which are included in the second factor. So we have the factor x to the power of 4 plus 5x squared plus 4, right? And 2x minus 1, which originally we found. Perfect. So we have actually factored. Now, can you factor x to the power of 4 plus 5x squared plus 4? Well, that will give you complex roots, right? So we have got the solution in such a short period of time, correct? So we could write our function f of x as the product of 2x minus 1 into x to the power of 4 plus 5x squared plus 4, correct? Now this could be factored. Let me just write down the factors for the quartic equation x to the power of 4, 5x squared plus 4. Well, it's like a quadratic equation, right? Where we're looking for sum and product of 4. So we're looking for actually product of two terms as 4, and sum of these two terms should be 5. The numbers are 4 and 1. And therefore, we could write this quartic equation as product of x squared plus 4 times x squared plus 1. So these become the other factors. So we do have a factored form. And clearly, in this factored form, we have complex roots, right? So the roots for us are 1, we have half. And for x squared plus 1, what is the root? Let me rewrite here. X squared plus 1 equals to 0 implies that x is equals to plus minus I, correct? And x squared plus 4 equals to 0 implies that x is equals to plus minus 2i, where, as you know, I squared is equal to minus 1. That's the complex number, right? So we do get the other factors. 4 of these factors are actually complex. Only one positive real factor. Do you see that? Well, for benefit of most of our students who do not really understand complex numbers so well, I've written the factored form 2x minus 1 times x squared plus 4 times x squared plus 1. And for others who understand the factored form, they can actually write it as, we could write this function as, let me write f of x as equal to 2x minus 1. Now this x squared plus 4, we know 2i is the factor of this. So it is x plus 2i times x minus 2i, and then we have x plus I times x minus I. So you can clearly see that we had this thought that the positive roots could be 5, 3, or 1. In this particular case, we got only one positive real root at x equals to half. All the other roots are the complex roots. And I hope in this example, you have also understood a strategy to factor a very complicated polynomial. Descartes' rule actually helps us to eliminate most of the possible factors and just focus on the ones which could be part of our solution. And that helps us to find a quick solution to such a difficult question. I hope it helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.